So in this problem, we are given the value of sine A, that's 3 over 5. Value of cosine B is 9 over 41. And it's also given here that the angle A and B lies between 0 and pi over 2. So 0 and pi over 2 means we are in the first quadrant. So that's the first quadrant. Our angle value is lying between 0 and angle pi over 2 radians. Using this information, we need to obtain the value of sine A minus B, sine A plus B, cosine of A minus B, and cosine of A plus B. Let us begin. Now, first what we'll do, we'll note down the formula for sine A minus B. So we have a compound angle here, A minus B, which is difference of two angles. So this can be expressed as sine A times cosine B minus cosine A times sine B. Then we have sine of A plus B. So this will be equals to sine of A times cosine of B. Now we'll have a positive sign here. And we have cosine of A times sine B. Then we have cosine of A minus B. So this will be equals to cosine of A times cosine of B plus sine of A times sine of B. And to find out the value of cosine of A plus B, we'll have cosine of A times cosine of B minus sine of A times sine B. So these are the four values of sine A minus B, sine A plus B, cosine of A minus B, and cosine of A plus B. So let's begin. Let's begin by finding out the value of sine A minus B. Now here we have been provided with the value of sine A as well as cosine of B, but we'll need to find out the value of cos A and sine B. To do that, we'll begin with sine A. So here we are given that the value of sine A, that's equals to 3 over 5. Now to find out the value of cosine of A, all we have to do is use the identity. So we know that cosine squared theta plus sine squared theta. So this equates to 1. Now we find out the value of cosine theta. What we can do, we can rewrite this equation as plus or minus square root of 1 minus sine squared theta. Fine. And similarly, to find out the value of sine theta, all we have to do is make it equal to plus or minus square root of 1 minus cosine squared theta. Right. So to find out the value of cosine of A, so we will use this particular formula. So we have plus or minus square root of 1 minus sine squared A. So let's plug in the value of sine A. So this means we will now get plus or minus square root of 1 minus 3 over 5 whole square, which will be equals to plus or minus square root of 1 minus 9 over 25. So when we solve this, we're going to get the value for 4 over 5, plus or minus 4 over 5. Now, we're getting here two values. One is a positive 4 over 5 and the other one is negative 4 over 5. So it's already given in the problem that the angle A lies between 0 and pi over 2. So that means A lies in the first quadrant. Now, what is the value of our cosine function in the first quadrant? We know that all trig functions are positive in the first quadrant. So that means our final value is only going to be positive 4 over 5. So now we have the value of cosine of A. So let's note this down. The cosine of A is positive 4 over 5. Then we are provided with the value of cosine of B. So cosine of B, that's given as 9 over 41. Fine. So we have 9 over 41. Using this information, we need to find out the value of sine B. So sine B will be equals to plus or minus square root of 1 minus cosine squared B. So we will substitute cosine B with 9 over 41. So we have square root of 1 minus 9 over 41 whole square. So when we solve this, we're going to get the value of sine B. So sine B will be equals to plus or minus 40 over 41. So we're getting two values. Again, B is also given that it lies between 0 and pi over 2, meaning B is in the first quadrant. So in the first quadrant, since all trig functions are positive, so we're going to get a positive value, positive 40 over 41. So this is going to be the value of sine B. Now that we have all the four trigonometric ratios, sine A, sine B, as well as cosine A and cosine B. So we can easily find out each of the values. So let's begin. So we'll first obtain the value of sine of the angle, compound angle A minus B. So sine A minus B, we have sine A times cosine B as the first term. So sine A, that's 3/5 multiplied to cosine B, so that's 9/41. Minus, then we have cosine A times sine B, so cosine A, that's 4/5 multiplied to sine B. So sine B is 40/41. So let's solve this. So we have 3 times 9, that's 27, 27/205 minus 160 divided by 205. So we have 160, negative 160 added to positive 27. So that's going to give us negative 133 divided by 205. So this is going to be the value of sine A minus B. Coming to the next one, we have sine A plus B. So sine A plus B, the first term is sine A times cosine B. So we have 3/5. That's the value of sine A multiplied to cosine B, which is 9/41. Plus cosine A times sine B. The cosine A is 4/5 multiplied to sine B, which is 40/41. So this is going to give us a value 187/205. Then we have cosine of A minus B. This will be equals to, so we have the first term cosine A times cosine B. So cosine A is 4/5 multiplied to cosine B, which is 9/41. Added to the second term. So second term is the product of sine A and sine B. So we have 3/5 multiplied to 40/41. So this is going to give us a value 156/205. And then finally we come to cosine of A plus B. So that will be equals to 4/5 multiplied to 9/41 minus 3/5 multiplied to 40/41. So this is equals to negative 84/205. So we have obtained the value of all the three trigonometric ratios, where we have, in the first case, the difference of two angles A and B. In the second case, we have sum of two angles A and B. And in the third and fourth, we have the difference in sum respectively.